Let's find the relative maximum and minimum of this function following this procedure. First, we find f prime because we need to analyze the slope, and then using the f prime, we find the critical number, and then we build our test interval, and then we test each test interval using a Sine chart, and then we draw our conclusion. So first of all, f prime of x using simple power rule. So f prime of x, so the derivative of x is equals to 1, and then 4 divided by x, that is 4 times x raised to the negative 1. So you bring the negative 1 power down, you have negative 4, and then negative 1 minus 1 is negative 2. And then the derivative of 3 is equals to 0. So now the derivative is done, and then you set the derivative equals to 0. So why do we need to set that equals to 0? Because a critical point happens when there is a horizontal tangent line, or you have a critical point when the first derivative is undefined, and also when there is a vertical tangent line. Okay, so before we proceed further, can you tell me that what's the domain of the function, the domain of the given function? So the domain, domain of f, what is this? So first of all, we have to say that x cannot be equal to 0, right? So that means the domain is from negative infinity to 0, and then from 0 to positive infinity. You can let x be anything you want except 0, because once x equals to 0, 4 divided by 0 is undefined. Why do we need to point this out? Because this affects the test intervals. What if you just have a polynomial? So let's say x squared plus x plus 3. Then for that polynomial, the domain is all real numbers. So in those type of problem, we don't need to worry about the domain. But in this one, we do need to worry about the domain. All right, so let's solve it. So we have 1 minus 4 divided by x squared equals to 0. And then we push the 4 divided by x squared to the other side. And then we multiply both sides by x squared, so we have x squared equals to 4, and then therefore, I'm trying to save some space in here, so allow me to rewrite this. I'm going to cut this, so this step, and then I will just do it horizontally. We have 1 equals to 4 divided by x squared, and then we multiply x squared on both sides, and then once you take the square root, don't forget that this is x equals to plus or minus square root of 4. So when do we use plus or minus? When the degree of x is even. So let's say x raised to the second power, 4th power, 6th power, 8th power, 10th power, 20th power, 100th power, then you have to use the plus or minus. And then the critical numbers are plus or minus negative 2. So this is my critical numbers. Some textbook call these critical values. They are the same thing, critical numbers and critical value. And then next, we have to build the test interval using the critical numbers and the domain. So what are the intervals? So let's draw a number line. And then we have x not equals to 0, and then negative 2 is a critical number, 2 is a critical number. So you have one line, one number line, you cut the number line 3 times, so you just cut the line into 4 pieces. The first piece is negative infinity to negative 2, and then negative 2 to 0, and then from 0 to 2, and then from 2 to positive infinity. So we have 4 test intervals. And then which interval is increasing, which interval is decreasing. Let's find out using a Sine chart. So for a Sine chart, we are going to set a table. So the first row of the table is the test intervals. And then we draw a line. And then we do this. So the first interval is from negative infinity to negative 2. And then the next interval is from negative 2 to 0. And then the next interval is from 0 to 2. And then the next interval is from 2 to positive infinity. So 2 to positive infinity. And then in the second row of the table, you have to pick a test value. Test value means you pick a number inside each interval. So we prefer to pick something easy. So let's say x equals to negative 3. You might be asking, hey, can I pick x equals to negative 1000? Absolutely yes. But when you plug in negative 1000 to the f prime to do some tests, you might have some big arithmetics to do. which is something that I don't prefer. And then from -2 to 0, I pick x equals to -1. This I pick x equals to 1, and then this I pick x equals to 3. So based on my experience in grading, I haven't seen any student picks anything crazy on the test. I haven't seen that. So if you want to pick something crazy, so let's say the last one, you want to let x be 3 million, go ahead, but that will just make the arithmetic really, really hard. All right, and then the next row, we have a test. We have to test the f prime. So what is test f prime mean? So basically you have to plug in -3 to f prime. How come we don't plug this into function f? Because we are analyzing slope. So when you are analyzing slope, you are asking f prime to do the job for you. If you're looking for a point on the curve, you are asking f of x to do the job for you. So here is how the job's done. So f prime of -3. So for the f prime, so we have 1 minus 4 divided by -3 square. This is how you do it. So this one I have 0.56. So for f of -1, so you have 1 minus 4 divided by -1 square. So that is 1 minus 4, that is equals to -3, and then so on and so forth. So this I have 0.56 or f prime, and then f prime of 1, and then f prime of 3, and then the rest. This one I have a -3, and then this one I have a 0.55, probably a 56 of 55. Anyway, I don't really care. So this one is 0.56, -3, and then -3, 0.56 or 55. I don't really care. What we care the most is that positive or negative. So this one is positive, this one is negative, this one is negative, and then this one is positive. What is a positive slope mean? Positive slope means the curve is going up. Negative slope means the curve is going down. Negative slope going downhill. Positive slope going uphill. And then the last row is conclusion. Okay. Up and down, what do we get? We have a maximum, right? And then down and up, what do we get? We have a minimum. And then what about the down and down? That means we have nothing. But what I want you to take a look at is the x not equals to 0 in the domain. So what happened when x equals to 0? The function is undefined. So in this situation, we have a vertical asymptote at x equals to 0. So this is a vertical asymptote. So that means never include this. This is only a vertical asymptote, right? So don't worry about the 0. Okay, so now we got a max and a min. So there is a max at where? At x equals to -2. There is a minimum at x equals to 2. Now, can you tell me the exact location of this point? Exact location means I need the y coordinate as well. So you have to plug it into the function f. So f of -2, that equals to, look at the top. So we have -2 plus 4 divided by -2 minus 3. So this is equals to -7. So point -2 comma -7 is a relative maximum. And then when x is equals to 2, so we have f of 2, that is 2 plus 4 divided by 2 minus 3. So this is equals to 1. So therefore, 2 comma 1 is my relative minimum. So in other words, for the relative min and max, they are called local maximum and local minimum. And for the plural, they call them relative extrema. Now, what is the graph look like? So I also built a graph for you. So let me pull the graph up. So this is what the graph looks like. We have the graph of the function, so which is f of x equals to x plus 4 divided by x minus 3. We already mentioned that x cannot be equal to 0 because when x is equals to 0, there is a vertical asymptote at x equals to 0. Right? So as x approaches to 0 from the left, y goes to -infinity, x approaches to the 0 from the right, y goes to positive infinity, and then the 2 comma 1 is your minimum, and then the 2 -7 is your maximum. And then what software did I use to create this? I use Decimal. It's a free app online. DESMO is a free apps online, so you can just go to Google and then search for Decimal, and then all you have to do is you input the function, and then they will show you the dot. Just simply hit the dots, and then they will show you that that dot. But they won't say maximum or minimum. You have to use your eyes to determine that by yourself. All right, so that is the end of this video. Oh, before I continue, please, when you do your works online, please, when you do your homeworks on exams online, please do the entire procedure. Don't cheat. Don't just go to the decimal, input the function, and then just input the answer. That is not going to help. All right. So if you find my instruction clear and helpful, give me a like, share the video for me. If you are new to the channel, please take 2 seconds, click the subscribe button for me. I appreciate it. It is worth coming back to my channel. I will see you all in the next one. Signing out.